All right, first we're going to explore the ellipse and what it looks like when we graph it and what the equation looks like. And then we'll graph some ellipses when we're given an equation. So first off, let's just draw an example of an ellipse. Let's say I have an ellipse and this is my center. So over 1, 2, 3, 4, up 3. So my center is 4, 3. And let's say the distance to the right and left, it goes maybe 2 to the right and 2 to the left. So I'm just going to write that down. From the center, it's 2 to the right and 2 to the left. And it goes up 4 and down 4. So these green dots I drew, those are called vertices. It's where it curves around and goes the other direction. So the way we use this information, if we're given that picture, is we use the standard form of an ellipse there in orange, and you subtract the x coordinate of your center. So it would be x minus 4 squared divided by how much the distance from the center to the vertices, to the edge, going right and left, just like the x-axis. So we went to the right, to the left, so it would be 2 squared. And then y minus the y coordinate of our center, so 3 squared, divided by the distance from the center to the vertices going up and down. So it goes 4 up, 4 down, so it would be 4 squared. So that's one example. Now let's do another, but let's have the center be right here at the origin. So the center is at 0, 0. That's our x1, y1. And let's say this one is 1, 2, 3, 4, 5, 6, 7. 7 to the right and left. So these are our vertices to the right and left. And let's say we go up 2 and down 2. So up and down, it's 2. So these are our vertices. This is our ellipse. So the equation for this one would be, if you look at the numerator, we have x minus the x coordinate of our center. So x minus 0 squared. Well, anything subtracting 0 is just that number. So that's just the same as x squared. And my denominator is how much we're going from the center to the right and left, just as the x-axis goes to the right and left. And that is 7. And then y minus 0 squared is just like y squared. And up and down, we're going 2 from the center. So it would be 2 squared. So this is the equation of that ellipse. Now let's try to use what we just learned here to graph when we're given an equation. So if you look at that, I have x squared over 25 plus y squared over 9 equals 1. So remember, the center is what is being subtracted from the x and the y before you square it. And there's nothing being subtracted from the x and y. So that means the center is right there at 0, 0. And then remember, the vertices are a and b. That's the distance from the center. So if a squared is 25, that means the distance from the center along the x-axis is 5. So I'm going to go 5 to the right and 5 to the left. And then if b squared is 9, then b is 3. That means the distance up and down, just like the y-axis from the center, is 3. So this is our graph. Now there's a couple of other things on this slide where we're finding the foci first off, and the foci is along the major axis, and the major axis is the axis of our, like this is an axis of our ellipse, and this is an axis of our ellipse. The major axis is the biggest one. So it would be going left to right. The x-axis would be our major axis in this case. It's longer. And so what we're doing is we are taking the square root of a squared, which is 25, minus b squared, which is 9, which is the square root of 16, which is 4. So it's saying from the center, we're going to go 4 to the right and 4 to the left. This dot right here is called our foci. And then eccentricity is a measurement of how round our ellipse is, how close it is to a circle. So we're taking the foci, the a squared minus b squared, and we're dividing it by a. So remember that's the square root of 16 over over 5, which is 4 over 5. So the closer that is to 1, the more round it is, the closer it is to a circle. All right, let's try another one. I want to show you this, and then this one right here, oops. This one right here is very similar, except instead of having 25 here and 9 here, we have 9 and 25. So the reason I wanted to show you this, I'm going to go through it quickly because we already know, remember, the center is at 0, 0. And we know the distance, in this case, the a squared is 9, so a is 3. This is saying that the distance going right and left from the center is 3. And then if b squared is 25, we know b is 5. This is saying the distance going up and down is 5. So this is a vertical ellipse. The major axis, the longer axis within our ellipse, is going up and down. So the reason I wanted to show you this one is because the formulas for the foci and eccentricity change then. Because if I were to do a squared minus b squared, I would have a negative number here, and you can't take the square root of a negative number. So the foci is actually the bigger number minus the smaller number. And the eccentricity would be the bigger number minus the smaller number divided by the bigger number. So you would get the same measurements for the foci. It would still be 4, but it would be 4 this way because the major axis is going up and down. All right, one more I would like to show you. And this one has a center that's not at the origin. So let's take a look at this graph. And what is the center? What are we subtracting from x? 2. What are we subtracting from y? 1. So let's put our graph, our center there at 2, 1. Now the vertices are the distance from the center. Remember, the vertices for the x, so going left to right from the center, is a, and a squared is 9, so a is 3. So from this center, I'm going to go 3 to the right and 3 to the left. And then the vertice going up and down on the y-axis, like the y-axis, is b. So if b squared is 4, b is 2. So from my center, I'm going to go up 2. That's one vertice, and down 2. That's my other vertice. So this is my ellipse. So remember, with the foci, you need to ask yourself, which is the major axis? Which is the biggest axis within the ellipse? And in this case, it's going left to right. This is longer than going up and down from the center. So the major axis is left to right, and it's a squared minus b squared. Make sure you're doing the bigger minus the smaller. And in this case, it is 9 minus 4, which is the square root of 5, which if you put that in your calculator just so you can plot it, it's about 2.2. Then eccentricity is the 9 minus 4 divided by a. Remember, a is 3. So it's the square root of 5 over 3, which is about 0.75. So this is telling us from the, 0.75 is telling us how round it is. I forgot to plot my foci at 2.2. That is saying from the center, I'm going to go 2.2 along the major axis. So 1, it's about right here. It's about right here. So this is a foci and this is a foci.